Beauty.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to week 3 of the VMware vSphere 6 Masterclass short course, which rolls nicely off the tongue, I think. This course is facilitated by IT Masters and ITPA, or Information Technology Professionals Association. Your mentor for today, indeed for the short course, is Robert Hudson. We've got plenty to get through today, so all I'll say is keep questions coming in via the GoToWebinar chat function. They've been really great, and also we're really enjoying what's happened in the forum so far. There's been a lot of beginners asking questions and people with more experience helping out, so it's been really great. When you do send your questions in, I'll try to answer any that are administrative, and we've also got Neil McCosh helping me with that today, so that's really nice to have him on board. Say good day to Neil. If we can't help, we'll tell you who to contact, or if they're relevant to the content of the course, then we'll flag them for Robert to answer periodically throughout the webinar. For now though, please welcome Robert for week 3.
Good evening all. Again, as has just been noted, this is the VMware vSphere 6 Masterclass, week 3, virtual storage. So we've already gone through what's new and the virtual networking. So today we'll look at storage, some basic information on how storage is utilized under the vSphere platform, and the various aspects of the different types of storage that you'll use. So this week what we're going to cover off is storage virtualization, what it is, how it differs from the traditional view of storage. We will look at using SAN storage with vSphere. So what is a SAN and what it is not, and what is often where the term is often misused. We will look at flash storage. We will look at the different types of data stores that are available to you in your vSphere environment and what they're used for. We will look at raw device mappings. They're a particular aspect of storage under VMware that it pays to be aware of under certain circumstances. And again, just look at what your lab setup will include. Now, we have a larger number of slides this week. I have listened to feedback and tried to incorporate some more pictures and graphics to explain what we go through in the wordage. So we shall move on this week and start with storage virtualization. So traditionally, and talking in the days before virtualization was a serious thing, storage had a one-to-one relationship between the server workloads and the storage devices. So basically a disk or a storage LUN had a one-to-one relationship back to a server. So only one server could access a particular disk or LUN. The problems this had was that it was inefficient, both in terms of capacity and performance. So the reason for the capacity inefficiency was that you may purchase a 100 gig disk as an example, or these days it might be a 1 or 2 terabyte disk, and only use 20 or 30% of that capacity. The rest of that capacity is not available to other machines. So you can't make better use of that storage. You generally have a single point of failure per workload. So each workload has its own point of failure. Now, the reason that's a problem is that the more individual workloads you have, the more chance you have of a single point of a single failure occurring. Yes, it doesn't impact on multiple workloads necessarily, but the chances are that you'll see more failures in your environment where you have more discrete infrastructure installations. So when we look at traditional storage and the way it was built, is that basically each server, as you can see there, has 2 volumes in this case, and each one of those volumes has some data and some unused allocation. So volume A may well be the system operating system disk, for example, and if you had 100 gig allocated to the operating system, you may find that Windows only consumes 20 or 30 gig of that, and the rest of that data is unused and cannot be allocated for something else. Windows can use it if it decides that it needs to increase the space it's using, but nothing else can use that. So if server B needed to use more space than it had allocated to it, it couldn't go and use unallocated storage from servers A or server C. And this is fairly inefficient. So what came out of that was traditional SAN storage. Now I say SAN. SAN means Storage Area Network. It is technically a description for all of the infrastructure that provides storage in a shared network environment. The misuse of the term SAN tends to be the storage provider or the storage device that is providing storage over the storage area network. Just so people know, yes, technically it's not the correct term, but it is full into common use, and I will continue with it on and off as I go. So basically, the way this works is that instead of each server having its own storage, you have a single pool of storage which is shared amongst the other workloads. So all of the servers gain access to the storage. So this gives you a many-to-one relationship between servers and storage devices. So you get better utilization of available space because you can allocate some of that what was previously unallocated storage. And if you look at this, this picture, your unused allocations are now actually able to be allocated to server D and server E because the shared storage device has multiple servers accessing them. You get better performance generally. Now the reason for this is that traditionally storage performance was limited by the number of spindles that were available. So each disk, with a rotating platter or plateaus inside it, could only provide a certain number of IOPS. And the way you traditionally increase the IOPS was to either spin those disks faster, which is why you get 5400 RPM, 7200 RPM, 10,000 RPM, and even 15,000 RPM spinning disks. But the other way was to increase the number of spindles. So two 7200 RPM disks are roughly as fast, all other things equal, if you're spreading your workloads across them evenly, as a single 15,000 RPM disk. If you put 10 10,000 RPM disks together, you effectively have 100,000 RPM to play with. So the way the SAN works was that instead of putting one disk in each of 5 servers, you then put 5 disks in the SAN and allocate storage off those 5 disks to each of the servers, and they all gain the benefit of performance. It removes single points of failure as well, and the reason for this is generally because of good design, in that you duplicate or replicate the likely points of failure. So in general, a SAN will have 2 power supplies. It will have multiple disks in it, including spare disks for if a single disk failure occurs, and also you will have multiple paths of connectivity back to your servers, so that if one path falls over for some reason, the server is still able to access the storage. Now, as I promised, more graphics. So here what you will see is that we have a number of physical workloads, and yes, Hyper-V and VMware are here, and they do have VM sitting on top of them, but ignore that for the time being, if you would. Each one of these server workloads utilizes storage in the SAN rather than using captive disk inside it. And what that means is that you're getting better or more efficient use of the storage. Storage virtualization expands upon that. And the reason for this expansion, I'll backflip to the previous graphic and to the next one as well, is that instead of having your SQL server, as an example here, as a physical host, which then has a connection directly into the SAN for block level storage. And that's where effectively, other than the network connectivity between the SAN and the server server believes the storage is local and treats it as such. Under VMware and storage virtualization, the benefit you get is your virtual machines, so you run SQL in a virtual machine, and it doesn't need to know anything about the underlying storage. All it knows is you've provided it with a VMDK file, which is a file which sits in a file system, which sits in a volume, which sits in a LUN on underlying storage. And your virtual machine knows nothing about the block storage, it knows nothing about the LUN, it knows nothing about the volume, and it knows nothing about the VMFS file system. All it knows is it has some storage available to it. Makes it very simple. So it reduces the complexity of storage management for your application workloads. It means that your application specialists, your SQL experts, your Exchange experts, don't really need to know anything about storage in terms of managing it. They need to know what performance and what characteristics they need out of their storage, but they don't need to know how to get it. Storage virtualization, through some of the features, thin provisioning is one of them, allows higher capacity efficiencies. So again, you might provision a LUN of, let's say, 2 terabytes, And inside that 2 terabyte LUN, you might provision 5 virtual machines with VMFS in the VMFS file system, each one of which is a 500 gig thin provisioned disk. So as far as your workloads are concerned, each one of them has a 500 gig of disk available to it, and you've actually provisioned that out of a 2 terabyte volume. So you've over provisioned there by 20%. As I mentioned, some of the enhanced features you get: thin provisioning, the ability to snapshot a virtual machine, the whole virtual machine in one go is one of the advantages. Migrations, so you can move virtual machines from one physical host to another because the storage has been virtualized and abstracted from the virtual machine. And those are some of the benefits you get. You also get later, and we go into when we talk about vVols, the ability to actually define what the characteristics of the storage that are required are and actually have the storage provision automatically according to those requirements. Storage vMotion is one of those, absolutely, yes. A question, is it best practice to thin provision? The answer is it depends. On some storage providers, they say no, don't thin provision because they're doing some thin provisioning work in the background. Thin provisioning has some caveats to it. If you put 2 1 terabyte VMDK files into a thin provisioned, into a 1 terabyte VMFS volume, as long as they never grow above an average of 500 gig each, you'll be fine. But if they do grow above that, then you actually fill your VMFS volume, which will then freeze your VMs. So you need to be careful. Thin provisioning requires a high level of management in order to ensure you don't have problems with it. So under storage virtualization, as I said, each one of these ESXi, and it says ESX, they're really ESXi hosts under vSphere 6, has a number of VMs on it, and each one of those VMs has its disk, its virtual disks, stored in a VMDK file. So the entire virtual disk that the workload sees in the virtual machine is really, as far as ESXi is, a single file in a file system. Ian has mentioned that in 3PAR, HP 3PAR, it is strongly discouraged as the SAN does it for you. That's in terms of thin provisioning. That is absolutely correct. In the all-flash models of the 3PAR, they also do zero dedupe. So they actually look at stripping extraneous zeros out of the storage that is actually dropped onto disk. And so in HP 3PAR land, on flash storage especially, the advice is that you thick provision eager 0, so that you actually write the zeros into the VMDK file, and those zeros are then stripped out by the storage. Pure Storage, Extreme IO, there are a number of storage providers who operate in that fashion. 3PAR is a little bit different. As I understand it, they're the only ones who do the operations in the ASIC rather than in software running on a CPU. A comment there that thin provisioning at the storage layer is better because it takes the workload away from ESX. That is absolutely correct, and certainly when you start looking at things like the VMware APIs for array integration, or VAI, that is exactly the whole point of those. That feature is to offload the storage operations from VMware or from the ESXi hypervisor, which has other things to do, to a storage provider that is generally really good at doing it. So how do you use a SAN storage device, or SAN storage in general, with vSphere? So block level storage can be provided to your ESXi hosts via a network, and that is done over either fiber channel over Ethernet, or iSCSI. Okay, so comment has been made by Anthony that I have spelt fiber channel incorrectly. In general, fiber channel as a name is spelt ER. I agree that as an Australian we should be using RE. In general though, fiber channel is spelt ER. It's just the way you see it everywhere. Yeah, I do agree. I would much prefer to spell RE, and in fact I had to go uncorrect myself when I wrote the slides. So when you use block level storage, it requires that ESXi is the controller in terms of creating the logical partition and the file system. And somebody's made a joke about spelling realize with a Z. Yes, well done. So in this case, all the storage provider really does is provide access to blocks of storage, and ESXi then controls how those blocks are utilized. So best practice for SAN storage involves redundancy. So you should have multiple ports per ESXi host. So you want multiple paths between your storage consumer, your ESXi host, and your storage provider. So multiple ports on the ESXi host dedicated to storage or utilized by storage. Doesn't have to be dedicated. You then want multiple network paths / switches between your ESXi hosts and your storage devices or your storage providers. And then you want your storage providers or storage devices to also have multiple ports on them. What this means is that there's no single point of failure for traffic overall between your storage client, which is your ESXi host, or your VMs with their VMDK files in the VMFS, and the disk. Multipathing, exactly. Thanks, Paul. And there's a picture here as well. Yes, in theory you should have two HBAs. That is absolutely correct, rather than a dual port HBA, because it is possible that a dual port HBA would suffer a failure that took both ports out. That is correct. And certainly in the environments I work with dual port HBAs or NICs, but then I use two of them. So as you can see here, and this is something that has been mentioned in terms of multipathing, that in this case, the two storage targets or storage providers are joined together and would pass traffic between them. Each ESXi host, and it says ESX again here, just the diagrams that are available, that's what they said, have two paths, so one path to each switch, and then each switch then has a path to the storage. Where this could fall over in theory is if the storage target 1 fell over entirely, it would be difficult for any of the storage that was held on that target to be accessed because there's not another path into it. The idea in this particular case is that these two targets would either both own shared disk behind them and be able to offer the LUNs up. If target 1 went down, target 2 could offer the LUNs that target 1 was previously managing. ESXi used virtualized storage system, absolutely. There's a lot of work done in ESXi over the years to move it from being a simple shared storage consumer to doing a lot of the storage virtualization itself. Are there any other storage devices that we can use? You need to use storage devices that are on the hardware compatibility lists, which are published by VMware. It tends to be, if you're looking at block storage, fiber channel storage, fiber channel over Ethernet, and that storage can actually be fiber channel with an intermediary switch, or iSCSI. Yes, Jeff, certainly best practice would be to mesh the targets rather than require that target 1 pass traffic for target 2 and vice versa. And there is an interconnect between them. Some storage, if you look at EqualLogic, will work in this fashion where they actually pass traffic between the controllers internally rather than meshing fully on the outside. If you wish to go that way, it is definitely better to mesh on the outside. So you would, in that case, have another connection between the switch on the left side and the storage target on the right, and vice versa. So fiber channel requires that you have dedicated specialized network infrastructure. So you can't use a standard Ethernet switch. You need a fiber channel switch. It's different. It speaks a different layer 2 protocol to Ethernet. Fiber channel gear tends to run at 1, 4, 8, or 16 gigabit per second. As you go through more recent iterations, those speeds have increased. So each host requires a fiber channel host bus adapter, or HBA, ideally 2. So addressing in fiber channel is done via a unique identifier called a WWPN, or a worldwide port number. Security is provided through two primary processes, and the best practice is to use both. So zoning. So zoning is when you take, as this is done on a switch, on a fiber channel switch, or a fiber channel director, as they're often called. And this is where you put ports on that switch into a group, and effectively say that the ports within this group can talk to each other. That's fine. There's nothing stopping that from occurring. But you might have multiple groups, and the ports in group 1 can't speak to the ports in group 2. The other way of providing security is through LUN masking, and this is generally done on the storage provider, or can be done on the fiber channel director in some instances, where you say this LUN can only be accessed by these particular HBAs or WWPNs. So what that means is you might say, and where you've got mixed workloads, this is especially important, that you may have let's say a physical Oracle server, and it has LUNs on the storage provider. So you do two things. One is that you would ensure, in terms of zoning, that the fiber channel switch ports connected to your Oracle server and to the storage provider are in a group so they can talk to each other. And the other thing you would do is on the storage provider, you would mask the LUN to say only the Oracle server can talk to the Oracle LUN. What that means is it prevents overwrite or interruption of service, where you might bring another host online on your fiber channel network and it can't see the LUN that belongs to the Oracle server, therefore it can't touch it, delete it, overwrite it, format it, anything like that. Yeah, it's basically firewalling. Yes, that is correct. Zones it's a little like, so someone has asked, are WWPNs in zones the equivalent of VLANs on a Cisco switch? VLANs are a broadcast domain boundary. There's nothing to stop, as long as you have a default gateway in each VLAN and the ability to route traffic between them, a host in one VLAN from communicating with a host in another. Zones specifically prevent inter-zone traffic. More like a firewall than VLANs. VLANs are not a security device. Don't fall into the trap of thinking, oh, these two hosts are in separate VLANs, they'll be okay, they can't talk to each other. That's not necessarily the case from a layer 2 or a layer 3 perspective. So, in fiber channel, and here we see an example of what I've just spoken about, where you have two servers. Each one of those servers has two fiber channel HBAs, so we're following the best practice here. You then have two fiber channel switches. Excuse my cough. Now, each one of these switches is running a fabric of its own. So you've got fabric A on the left switch and fabric B on the right switch. Then down the bottom you've got your storage providers or storage processors, and they each again have two HBAs, and each one of those participates in both fabrics. So what this means is that either host can talk to either storage processor no matter where there is a single point of failure. Now what you may do is that if you had a LUN on storage processor on the right that was only meant to be available to server 1, you would then mask that at the storage processor level to ensure that only server 1 has access to the LUN, that server 2 cannot see it. That would prevent server 2 from ever interrupting the storage processes going on the LUN for server 1. So, fiber channel over Ethernet. So, fiber channel over Ethernet is basically a way of encapsulating fiber channel protocol, the layer 2 frames that belong to fiber channel, on the more readily available Ethernet network infrastructure. So it encapsulates them within Ethernet frames. So yes, Paul has made a comment there that although fiber channel is different from Ethernet and follows a different OSI model, basically WWPN zones is done at the same layer as VLAN does in Ethernet. That is correct, yes. A LUN, I've been asked, what is a LUN? A LUN is a logical unit number. It is a way of addressing a particular storage device or a storage allocation. I would suggest go and read my storage primer that was linked at the start of the course. I think it's linked to the week 3 as well. If not, I'll ensure that it is. but certainly that explains what a LUN is. It also talks about blocks, it talks about tracks, it talks about sectors, it talks about a few different things. So, Fibre channel over Ethernet, going back to topic, maintains the fibre channel addressing scheme and security options, so you get zoning and masking over FCOE. It works best on faster Ethernet infrastructure, 10 gig and above. It provides the possibility for converged network infrastructure. So you can have multi-purpose equipment, you can have a CNA or a converged network adapter, you can have fibre channel over Ethernet capable switches that can also function as standard Ethernet switches. Devices would be things such as Cisco Nexus devices, Brocade VDX switches, things like that. They're able to carry standard IP Ethernet traffic and fibre channel over Ethernet traffic on a single device. It allows for reduced infrastructure complexity. It basically means you can have fewer devices able to service your storage network and data network requirements. And that gives you reduced infrastructure cost because you can have a multi-purpose core switch. The other thing it can do is that you can use it for an FCOE switch as an intermediary device between Ethernet capable servers, as an example, and fibre channel capable storage devices. So it allows you to mix and match your port types, whereas on pure on pure fibre channel you are restricted in terms of the physical connectivity. Sean, I will make sure the storage primer is added to the week 3 section. It is in the introduction section at the very top of the course information. What is my opinion on FCOE versus fibre channel for performance? In the end, 16 gigabit fibre channel is roughly 1.6 times as fast as 10 gigabit fibre channel over Ethernet. I say roughly because there's a little bit of protocol overhead in doing it over FCOE, but in general, for a given performance level, in terms of the underlying speed capability, that they're equal on a megabit per megabit, roughly. Does FCOE use standard Cat6 or Cat? Yes, it's cables. Yes, it does. It basically uses standard Ethernet cabling. The impact if below 10 gig is that you'd probably be better going back to fibre channel because you can pick up 8 gigabit per second or 4 gigabit per second gear really, really cheap. Latency roughly the same. You might find that FC is dedicated and therefore is a little bit less latent because the fibre channel switches tend to be designed for low port-to-port latency. You can get, and I mentioned before, Cisco Nexus and Brocade VDX switches which have extremely low port-to-port latencies. And also have very large buffers on their ports as well, so you don't have to worry about buffer size becoming an issue for your storage network provider. So here as an example, and I mentioned this before, you see your data center LAN or your data network traffic on the left at the top here, and you'll see your fibre channel SAN on the right at the top. And what you've got is you've got these switches in here at the moment which interface between fibre channel on one side and standard Ethernet on the other. So it gives you your converged network core. And these are your servers with what they call CNAs, converged network adapters or storage adapters, and they are able to talk into this environment. And so with a standard Ethernet adapter, you're able to talk to both fibre channel and Ethernet connectivity. Question, does the 6 or 6A cable requirements and the max cable length apply for FCOE? Yes, it does, because again, it's fibre channel protocol encapsulated in Ethernet. So all the standard Ethernet requirements and limitations apply. Can you trunk 10 gig ports in FCOE? I'm not sure, to be honest. I suspect there is a level of that possible. I'd be very surprised if you couldn't, but I have never done it myself. FCOE is not something I've personally run into. I've just not had a need for it. If I've gone to Ethernet devices, I've tended to go to iSCSI. I've had a lot of people say that whenever they run into storage problems in VMware, the first thing they ask is it iSCSI? And if someone says yes, they nod knowingly, iSCSI, that always causes problems. I've never had storage problems caused by iSCSI. I've had storage problems caused by poor configuration, by poor management. I've never had performance or availability or reliability issues caused by iSCSI, ever. And I've been running VMware for a long time. iSCSI. iSCSI allows the standard SCSI command set to be sent over TCP/IP networks. So it actually relies on IP addresses. And so each one of your endpoints will have an IP address, and the traffic is routed and it sits on layer 3 between your endpoints. So it utilizes existing Ethernet network infrastructure. This is different to Fibre Channel over Ethernet, where you need to have gear that can do both. You need to have gear that can do Fibre Channel over Ethernet and Ethernet if you want to do both. If you want to do standard data networking on Ethernet and iSCSI, you just need Ethernet capability. One thing is you cannot run Fibre Channel over Ethernet into a standard Ethernet switch. It won't work. Your switch needs to be FCOE aware, which is why you need to go for devices like Cisco Nexus or Brocade VDX, or I'm sure Juniper have a device in that place. I just don't know what it is. And I'm sure Dell do, and all the other storage network providers as well. So, as I mentioned, iSCSI uses existing Ethernet network infrastructure. You don't need to buy a converged network infrastructure to do both. You just buy what you're already buying. There are some caveats there. You don't want to buy devices that have small port buffers on them, because iSCSI tends to have issues with small buffers. You want fairly low latency for storage. You want 10 gig or multiple 1 gig interfaces, and you need to be able to connect those all up. Addressing is done by IQNs, which is an iSCSI qualified name. So you will see, and when you start doing your labs, and especially if you have access to some iSCSI gear, that when you look at an iSCSI device, and be that the client or the server end, that each device has an IQN number. You can even look at it if you load the iSCSI service on a Windows box or in Linux. Shane has mentioned this slide is different. I made a very slight variation very late. I will upload a new copy though. So addressing is done via IQNs, which take the format of IQN dash, so you know it's an IQN, a 4-digit number, which is the year, followed by a 2-digit number, which is the month, and then the naming authority. And that naming authority is basically the DNS name of their primary domain in reverse. So you'd have IQN-2004-10.com.vmware followed by a unique identifier, which tends to be based on the hardware MAC address, I believe. But it's a unique identifier. So in Fibre Channel, where you did LUN masking and zoning for security, in iSCSI, LUN masking is fairly much the same, but then you would use CHAP authentication, which can be 1- or 2-way, and those two methods are considered to be the best practice in security. I believe encryption over iSCSI has come in 6.5. I don't think it's currently available in vSphere 6. I happen to be corrected there. Now, native support for iSCSI is built into vSphere through a software iSCSI adapter, or you can use dedicated hardware, such as a hardware iSCSI adapter, to allow boot from iSCSI. So with Fibre Channel, you can boot a device from a Fibre Channel provider in general, because you tend to use hardware adapters where the ability to connect to the storage provider is built into the adapter. In software iSCSI, so you can actually boot, so to go back, you can install ESXi onto a Fibre Channel connected volume and install ESXi in there and boot the ESXi host from that volume. So you can boot from SAN. So your server doesn't have to have local storage. Using software iSCSI, that's not possible, because you end up running into a chicken and egg situation where in order to connect to the iSCSI software, ESXi has to have booted because it's a software adapter, but you can't boot it unless you can connect to the storage. So you end up in a bit of a chicken and egg situation. However, if you're using a hardware iSCSI adapter, it is possible to boot from SAN. Now, iSCSI is routable over layer 3 networks. Fibre Channel is not. Fibre Channel over Ethernet, you can extend It's not strictly routable because it's over Ethernet. It's a bit different. There are ways to do it, but it's not as simple as routing. It's not as simple as routing IP traffic, which almost all basic routers can do this for you. You don't need specialized equipment for this. You can extend fiber channel over Ethernet over large distances with dedicated equipment to do so. iSCSI supports any available Ethernet network speed and also takes advantages of jumbo frames. Now, it is actually theoretically possible to use jumbo frames on fiber channel. I haven't seen it in use yet. I'm sure it's out there. Whereas for iSCSI, jumbo frames are almost universally recommended. There's some information out there that says that it may not make a massive difference, but in general, if your networking gear will support jumbo frames, then your storage provider will support it, then you should configure it in ESXi as well. So basically the way it works is that if you take, and I think I mentioned this in a previous webinar, but if you take a standard Ethernet frame of 1500 bytes where, let's say the header is, just for the sake of simple argument, the header is 300 bytes and the footer is 200 bytes. Of that 1500 bytes, you've only got 1000 bytes as a payload. If you go to jumbo frames where the frame size is 9000 bytes, then the 500 bytes pales in comparison to the size of the workload. Whereas in a standard Ethernet frame, it's about the footer and header account for a third of the entire frame. So you end up getting more payload per frame across the network with jumbo frames. You can do the same with fiber channel. I think the standard frame size for fiber channel is around 1200 and something bytes, and you can extend it to around 9000 as well. The question, have I experience using iSCSI over metro networks with a 10 to 15 millisecond round trip? Yes, I have used it over metro networks, over a WAN 150 milliseconds. That's starting to get nasty. The recording of the previous class should be up on both the learning portal and also it's been uploaded onto YouTube. In fact, that's of both the previous classes. So I'll leave that one for now because we'll try to focus on the topic because we've got a fair bit to go through as yet. So that's iSCSI. And here is again a diagram. So what you have here is that each one of your ESXi hosts, and there's one on the left, one on the right, one has basically physical iSCSI cards or hardware iSCSI cards. The one on the left has standard Ethernet network cards. So the software iSCSI adapter is then run by ESXi to then provide connectivity to the VM kernel ports on the vSwitch, which are then uplinked to your physical NICs, which then traverse the traffic onto your standard network. In the case on the left, you would possibly be using those physical NICs for data networks as well. In fact, you could do it on both. But what this means is your IP network can have iSCSI storage on it, and your host can communicate with that iSCSI traffic, or you may also have other servers or other, your clients, network clients on that IP network as well. So Gordon, you've mentioned, so you've tried iSCSI on vSphere today and found that there was a one-to-one relationship between a VMK and an uplink port. There are things you need to do in order to load balance or spread load across multiple ports. You basically need to create a VMK port per physical port you have, and then connect multiple VMK ports into your iSCSI adapter. I have some documentation on that I'm happy to share on the forums. If you want to post something about that, I'll run through that. It's something you have to do, a particular way of doing it. It does work, but yeah, you do have to have a one-to-one relationship between VM kernel ports and uplink ports, but you can multipath across multiple VMK ports. So the multipathing is done at the VMK level, not the physical port level. Flash storage is the next topic. So ESXi will try, under version 6 especially, to auto-detect flash storage, and there's a bracket there that shouldn't be. I shall fix that later. So storage can also be manually marked as local flash storage if detection fails. The reason this is important is that once storage has been marked as flash, you can use it for a variety of things. Virtual SAN. So in order to run Virtual SAN, and we get to that in a little while, you actually need flash storage available. In order to deploy a Virtual SAN, there must be flash available, or storage that is marked as flash. You can use flash storage for standard VMFS data stores. So you have very fast data stores. So if you have workloads that need high I/O, such as log files or data files sitting under transactional SQL databases, you can use flash storage for those. And you can also create something called a virtual flash resource, or a VMware. It's basically VMware optimized for flash, VMFS, sorry, optimized for flash. However, it's only usable for non-persistent data. So you would use as a read cache for your VMs, or you would use it as swap cache for your ESXi hosts. Flash storage is, as opposed to more traditional spinning disk storage, where the data is stored in flash chips, or they're NAND chips they tend to be they multi-layer or single layer. It's instead of an opto or an electrical mechanical storage device, it's a pure electrical storage device, much faster than spinning disk in general for certain workloads, but has some issues. Again, look to the storage primer. If I haven't specifically mentioned flash in that, I did write it a while ago, then please point that out, and I will put something up about flash. But flash storage is SSD drives. In general, it is the way they tend to appear, although these days you've got things like M2 flash, which are connected directly to the motherboard instead of being connected through an IDE or a SATA bus. Generally, much faster disk. It has some, or much faster storage rather than disk. There are some caveats in terms of the number of read-write cycles it can cope with. So, data stores. So there are two primary data stores that have been used traditionally under VMware, and they are VMFS, or the VMware file system, and NFS, or the network file system. There are, since 5.5, two new data store types. So Virtual SAN, or vSAN, which I've just mentioned before, requires flash storage, which was introduced in vSphere 5.5, and that's where the bracket went missing from, apparently. And also virtual volumes, or vVols, which were introduced in vSphere 6. So these two newer ones in particular are getting much more along the software-defined storage or the storage virtualization path. VMFS and NFS were part of the way along there, but have been improved upon. So VMFS is supported on fiber channel over Ethernet, and iSCSI storage, basically block level storage. It is used, and also local, sorry, I should say here also local storage. So if your server has disk in it that is accessed through either a SATA or a SCSI bus, or, and my mind has gone blank on the other standard bus that is used, excuse me, could be fiber channel actually in some cases, but in general, any local storage, no, not IDE, the enhancement over SATA, and I can't think of the SAS, thank you, that's the one. And we have a number of winners, and they're all coming through. That's one way to get the questions up.
Everyone gets a prize.
That's right, the prize is some knowledge.
Yeah.
So yes, SAS, thank you, which is serial attached SCSI, funnily enough. So it's still the SCSI protocol being used. And just because I can hand out some information, SATA is effectively a subset of SAS. So it is a cut down version of SAS, and in fact you can in theory connect a SATA disk to a SAS controller. The other way around, not so much, because the SAS disk expects different commands or more commands to come from the SAS, from its controller. Buckets of kudos, yes, absolutely, have some buckets of kudos, thank you. So generally, VMFS is used to store your virtual machine files, your VMDKs, VMX files, there's vSwap files, there's, basically the files that make up your virtual machines. You can also store things like ISO images, templates, things like that in there as well, but in general, the thing that's used most is for virtual machine storage. So VMFS allows multiple hosts to share the storage. So it tracks which, oops, sorry, and I'll scroll when I shouldn't have, which host owns a particular VM by way of lock files. So effectively, when a virtual machine is booted on a host, a lock file is written into the VMFS volume indicating that that host owns that VM for the time being. What that is used to do is to prevent two hosts from trying to bring up a VM at once, which would cause issues. You also then, there is some locking done at the VMFS volume level to ensure, to allow your hosts to have access to the volumes, and occasionally you will find that you will try to delete a volume you think is no longer in use, and it errors saying no, something's got the volume locked as open still, in which case you have to go and use the VMFS tool, the VMFS tools within the command line to basically drop the connection. It gets a bit complex. Again, if people want to know about it, more than happy to discuss it in the forums. So VMFS supports on-the-fly volume size increases, which is really nice. So if you provision a, let's say, a 1 terabyte LUN, and you've got 5 or 6 VMs sitting in there and you're starting to run close to your storage capacity, you can actually go and increase the size of the LUN at the storage level to 2 terabytes. You can then go to VMFS and say, extend this and take up the remainder of the space, please. And that is done in a hitless fashion, in the fact that there is no negative impact, as long as everything goes right, it generally does, to your existing workloads. So you don't need to vacate your VMs off it in order to extend the size of the volume. Certainly those of you who have run Windows for a long time will know that prior to Windows 2008 R2, you could not extend the volume size of a system volume while Windows was online. You had to do it with Windows offline. Microsoft improved that in 2008 R2, and you can do it on the fly now as well for system volumes. You've generally been able to do that for NTFS for non-system volumes for a while. Not decreases, no. Decreases are still a little bit contentious, I believe. Yeah, I would not recommend reducing the size of a VMFS volume on the fly. I don't think it's possible at the moment. It might be a 6.5. I have not seen it supported under 6 in my experiences. You can on Windows as an example, and I'm sure Linux can do it, and it's the variety of file systems it supports. But yeah, at this stage, no. So the maximum LUN size is 64 terabytes. That's actually, so that's the maximum LUN size that you can then connect sorry, I shouldn't say LUN here, I should say VMFS volume size, sorry. It's 64 terabytes under VMFS 5, which has been created by an ESXi 6 host. If you upgrade from VMFS 3 to 5, which is an operation you can perform, the maximum LUN size is still 2 terabytes. Volume size, sorry. The maximum VMDK size, so the maximum individual file size is 2 terabytes. The block size in the VMFS volume has dropped to 1 megabyte. It used to be that you could choose between 1, 4, and 8 megabytes, and the larger the block size you chose, the bigger the volume you could create, but then the larger the smallest piece of data you could write was. So if you try to write a 1 meg file into an 8 meg block size file system, effectively what happened was you wrote 8 meg and you lost the other 7 that you weren't using. So with VMFS 5, VMware improved the file system so the block size is 1 meg. Does a VMDK file equal a LUN? As far as the guest OS is concerned, yes. Effectively, it is seeing a virtualized physical device. As far as your storage device is concerned, it presents a LUN to ESXi. ESXi then creates a volume in that LUN. It then creates a file system within that volume, and within that file system, your VMDK files are written. The 64 terabyte without extents. I think you are correct there. Is per. I am really not a happy person with the way the extents were provisioned in the past or provided in the past, where you could join multiple extents into a volume. It was kind of like, if people who understand storage a bit, JBOD, or just a bunch of disks, that if a single extent within that VMFS volume failed, the whole volume crashed. It was really asking for trouble. So a LUN is a logical unit number. It is a physical presentation of storage out of the storage provider, which is then consumed by a server or a client. So there's a question, please explain the difference, the difference between LUNs and volumes. A volume is a logical construct that is written into a piece of storage into which a file system is written. So that you can basically think that the LUN is the physical storage that is being presented, and the volume is written by the server that consumes that storage. Yes, the volume is controlled by the operating system, that is correct. Thank you, Paul. Whereas the LUN is controlled by the storage provider, the underlying physical storage provider. So getting back to the slide, if we may, so there is a maximum of 256 VMFS volumes per ESXi host. You can't address more than that. VMFS 3 and 5 are both supported under vSphere 6. And I mentioned this before, a new VMFS 5 volume has higher limits. So the higher limits that I mentioned here are for a brand new, created from scratch VMFS 5 volume. If you upgrade from VMFS 3 to VMFS 5, you may run into some problems in terms of you won't have access to the full limits. I think the per volume maximum is still 2 terabytes, as an example. So NFS, and this is the other option that is available to you for storage. So network file system volumes are accessed via VM kernel ports, so in a similar way to iSCSI is. There's a maximum of 256 NFS mounts per ESXi host, so the same as there are for VMFS. So the way that ESXi talks to NFS servers is through an NFS client that is built into ESXi. Although I put it here that the NFS client built into ESXi supports both 3 and 4.1 versions of NFS. The truth of the matter is there's actually 2 clients, and one of them supports NFS version 3 and the other one supports NFS version 4.1. That's interesting. So John has mentioned that VMFS 5 can have a VMDK of up to 62 terabytes. That's interesting. I'll take that on notice and see if I can get that clarified. I know there's some issues around 64 terabytes minus 512 for metadata and things like that, but I thought that was on the volume size, not the VMDK. But yeah, leave that with me. I'll confirm that one. So using NFS, basically what it does, it offloads all the storage management operations to an NFS server. So instead of ESXi having to manage VMFS itself, so telling the storage underneath where to write the data, how to write the data, when to move it, it offloads all those storage operations to the NFS server. Basically says, here's some data, write it somewhere for me, and then let me read it back. And that's largely the extent of the work that it does. So it presents a file-level storage option to ESXi hosts. So basically, the way this works is that all the ESXi hosts see is, or all they have control over, is the files that are operated on. The underlying storage is not visible to ESXi. So the file system is written by, or is controlled by the NFS server, and it can be things like, it could be NTFS if you had a Windows server running NFS services. It could be any one of a number of file systems on Linux that are available, ZFS or ext3, or a number of different file systems. The difference between block and file storage, again, I would suggest go to my storage primer. I believe it goes into it. But to summarize here, in block level storage, the operating system is responsible for creating the volume and saying, go write this data to here, 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 and it tracks on which blocks of storage each file is written. File level storage, the operating system says, here's a file, write it for me. Now let me read it back. And it lets the storage provider determine where and how the storage, the data is actually written to the underlying storage. In the end, your file storage system has block level storage underneath it. It's just a matter of where the client is responsible for determining, or at what point responsibility for how and where the files are written is, who has responsibility for it. So as I've noted here, the limitations of the NFS server apply. So if you're running an NFS server on Windows, then the limitations in terms of the file system size, the volume size, how large the files can be, are down to the NFS server's own limitations. And so what I have here, I mentioned before, the ESXi can consume either NFS version 3 or NFS version 4.1 storage. So there are some differences here between the two. So in terms of multipathing, or can you use multiple VMK ports to talk to multiple ports, network ports on your storage provider to allow you more bandwidth? Under NFS version 3, the answer is no. There's basically a one-to-one relationship on the TCP/IP stream, on the network stream between the storage provider and the storage client. Under NFS version 4.1, yes, they do what they call session trunking, which basically allows you to open multiple sessions concurrently. Hardware acceleration is supported on NFS version 3, but not on 4.1. What this allows is things like thin provisioning, where the VMware determines whether thin provisioning will occur or not. Under NFS version 4.1, basically what's happening there is that some of those options are being left to the NFS storage provider to make the decisions on. So encryption support. NFS version 3 does not support encrypted traffic. NFS version 4.1 does. Non-root access support. Now this is a quirk with NFS where in order to have read-write access to the file system that underlies the NFS service, you had to authenticate effectively as root into the NFS service. Excuse me. Under 4.1 that's not required anymore. So it's an enhancement where you don't need to give out your root access details on your NFS box in order to connect to the NFS volumes. And that's required for read-write or multi-party read-write in particular, where, again, multiple hosts share access to storage. There's an option under NFS called something root quash, I think it is. Those who are familiar with running NFS will probably, there you go, quash user. Thank you, Gordon. You've read my mind. So that was required under version 3 in order to allow shared access to the NFS volumes. That's no longer required on NFS version 4.1. No root quash yet. Quash or squash? Squash, sorry. There you go. I was almost right. The question's been asked, can you quickly summarize what overheads NFS has over iSCSI? Really, iSCSI gives you more control over how the disk, the data is written to disk. NFS, you're relying on an external storage provider to do some of that higher level work. It means offloading, and that can be a good thing for VMware, where again you're not expecting your hypervisor to manage storage. It's a task that again you're handing to a device which is effectively better at doing it. The counter to that is if you start looking at the vSphere APIs for array integration, or VAAI, as I mentioned earlier, which are basically a set of commands through the API that effectively do the same thing. Rather than the ESXi hypervisor saying, right, write this block to this, like this data, this piece of data to this block, write this piece of data to this block, write this piece of data to this block, and so on, which takes a lot of time and effort. It says, here's a bunch of data, go write it to disk and tell me when you're done. That's effectively what VAAI does. It means there's certain operations that are offloaded to the storage provider or the storage system that storage systems are really good at, and ESXi doesn't have to worry about it anymore. It's not something that's it's particularly good at, and it's not its core purpose. Its core purpose is serving virtualization workloads, not in managing storage. The question's been asked, what sort of workloads would you use NFS for versus iSCSI when evaluating performance? I think really what it probably comes down to more than that is what do you have available in your environment. Now, if your environment is already running a lot of NFS and you've got really good admins at NFS and you're really happy with the way you manage NFS, then use NFS. If, however, you've got a bunch of block storage and you don't have NFS and you don't have experts in it and you'd have to go invest time and effort and money in running NFS over top of iSCSI or over top of whatever block level storage your NFS runs on, then you'd probably stick with iSCSI. It depends, yeah. Performance-wise, not a lot of difference. certainly under NFS version 4.1, where your session trunking is now available, effectively the multipathing support that came with iSCSI is now available as well. There's a little bit of overhead in terms, and I'm saying a little bit of overhead, in terms of you're encapsulating storage in a slightly more header and footer, more metadata on NFS than you are through iSCSI, but then you're getting the benefits of you just offloading the work. Should VMware boot, so ESXi, I assume this means, from SAN or local disk or flash card memory? Another case of the answer is it depends. I personally order my ESXi hosts with onboard flash card storage. The ESXi installer, the footprint of the ESXi when it's installed is somewhere less than 150 megabytes these days, so you can install on a 2 gig flash card very easily. Boot from SAN, you can order your host with no storage as long as you've got the storage infrastructure to support it and have the storage admins to manage it. It depends. It really depends on what you're looking to do. There's no firm answer on that one. Virtual SAN, and I was cognizant of the fact that we've hit 9 o'clock. So virtual SAN is this enhanced storage virtualization. It's software-defined storage. It is supported directly out of ESXi, does not require a separate virtual appliance for management or to provision virtual SAN. So it's very simple to manage. Basically, you enable the feature on a vSphere cluster, and all empty directly attached disks on your ESXi hosts are added to the vSAN environment. Turn it on, any disk that's currently unused that's attached to your host will basically be added to your vSAN. So what it does, it aggregates all the included storage. So you might have a local disk on each of your hosts, and it aggregates them as a single shared data store available for VM storage on all hosts. Basically, it's a VMFS volume made up of multiple underlying disk units. Now, it includes redundancy. I would not use vSAN for remote storage. That's not the point of it. If you could mark storage as local, which you can, because you can mark storage as flash and you can also mark it as local. So in theory, you could do it, but it's kind of the whole point of vSAN is to give SAN-like benefits, shared storage, to non-shared storage. So it includes redundancy. What it does is it stores 2 copies of any data that's written to it. So if you've got 3 hosts, and each one of them has a 500 gig free disk sitting in them, then you end up with 1.5 terabytes of disk, but you only end up with a 1 terabyte volume, because there's always in fact, is it 1 terabyte? Yeah, about 1 terabyte, because every piece of data is written twice. So yeah, it's like RAID across ESXi hosts. That is correct. Now it does require good VM kernel connectivity, stored as objects, not blocks. It effectively forms a VMFS volume, and then it manages where the data is stored on the underlying storage. So in terms of object storage, yes, you write VMFS volumes into it, or VMDK files, sorry, into the VMFS volume it provides. Is it really object storage? You could consume it as if it was object level storage, but really it's not. Does it use a special VM kernel port? I believe it uses the management port. It's not really an object store, it's a VMFS volume, effectively. It's similar to RAID without the disk size requirement. To a degree, yes. It aggregates all the disks, and then instead of the way that RAID 5, RAID 6, and RAID levels like that work, instead of striping the data across them, basically it writes multiple copies of the data and stripes. Yeah, the underlying, I'm not terribly across the underlying processes underneath it. I'm aware of what it provides as an outcome. I believe it is in standard. In fact, I'm fairly sure it's even in the essentials package. Actually, it's a fairly low level inclusion in the licensing structures. Do you still need an SSD drive per host? I believe that is the case, yes. There's a requirement for flash storage in each host in order to participate in vSAN. However, as I mentioned earlier, in theory you can go and mark a disk that was not detected as flash, and that will qualify it in an unsupported fashion for vSAN. How does it ensure that it writes a second copy on different disk to eliminate failure? Magic. No. Algorithms. There are underlying algorithms in the product that are designed to ensure that it doesn't write the data to the same disk twice, or to two disks in the same host. So as you can see here, so what you effectively get is on each ESXi host, or ESX as it shows them here again, there are physical storage devices. And as you can see, each one of these has an SSD in it. And so what happens is that your vSAN data store, as far as your VMware is concerned, is here, and it writes 2 copies of the data, plus there is a witness server that is used and it's the witness server that really ensures that the data is written to multiple locations. So the witness is magic in this case. Basically, it's a way of making use of captive or in-host storage in a fashion that allows it to be available to multiple hosts. Certainly in the past, with earlier versions of ESXi, any storage that was in the host was only available to that host. It was, in theory, possible to make it available to the entire cluster, but then it became a single point of failure. I think 3 is the minimum, because you need that witness. I believe that might be the case. Now, virtual volumes. So virtual volumes further, expands again, there's yet another error in my slides, on the idea of software-defined storage. So instead of storing your VMDK files in static VMFS volumes, it stores them in containers which are based on storage policies. So what you do is you define a storage policy which might say, I need to have snapshots of this volume, or I need this volume to have a particular IOPS capability. And then when you define your virtual machine, you say, I want volume 1 to be snapshotted, and I want volume 2 to have this IOPS capability, and volume 3 can just be whatever else is left available. And as your VMDK files are formed, they are dropped into these containers, which are then, the containers are made up of the storage that meets the requirements, and that they're bundled together into what they call a vVol. And effectively what you end up with is a vVol per VM, and that vVol is then made up of a number of different VMDK files sitting on different storage based on policy. As I mentioned, it gives you granular control of your storage workloads. So you can define that you have a virtual machine that's running databases that says it needs fast storage for its databases and logs, or you might have another VM which says I only need slow storage for bulk file storage. And then as you define the requirements of the VM, the storage is automatically provisioned for you. It removes the idea that your virtual machine administrator needs to understand, that VMFS volume 5 is on SSD and VMFS volume 6 is on nearline SAS. And so because your policy defines which storage meets the requirement, when you say I need this machine to sit on storage of this policy type, those deployments into the correct storage tiers are done for you. It's a little bit, so John has asked that what are the benefits of vVols over using storage I/O control where you create gold, silver and bronze level LUNs and provide them to the hosts. Gold, silver and bronze level LUNs is basically around IOPS and that's it. So it's a very simplistic way of looking at what your storage capabilities are. vVols expands upon that. As I mentioned, you can have snapshot capability. There's other capabilities that can be involved. You can say this volume is replicated or this storage is being replicated. It enhances. It goes beyond what storage I/O control allows. It's also, you can go change the policy on a virtual machine and the storage will be migrated automatically for that virtual machine. Is it expensive? Look, it requires that the underlying storage provider, your SAN, your storage device, supports the VASA, the VMware APIs for storage awareness, and also VAAI, which I've mentioned a couple of times already. Generally, newer storage arrays, yes, they tend to be more expensive. There are also, on some of them, limitations over which protocols you can do it. So as an example, I am quite intimate with a HP 3PAR 7200C, which can do both fiber channel and iSCSI. However, it cannot run vVols over iSCSI. It's not certified to do so. So there are some caveats or requirements that need to be met by all of the environment in order to allow virtual volumes to be used. No, it's not only Enterprise. Well, these days I guess it's Enterprise Plus because they've dropped Enterprise. I've worked in environments and have access to environments where they're using VMware vSphere Enterprise and have access to vVols. I'm not sure if it's available in standard. I'd have to check. But certainly it's taking the software-defined storage level to the, or the software-defined storage idea to the next level. You need, Jerry has asked, if you don't have a current vVol enable on 3PAR and enable it, will it affect the current VMFS volumes and LUNs? No, it doesn't. They can coexist, so vVols can coexist with other VMFS volumes. So they don't impact on existing storage. So if you go provision vVols and have the capability of doing so, so your storage meets the requirements on a 3PAR, it should, as long as you're not using iSCSI. So they can work together, absolutely. But you have to have the vVol configuration done when you create the virtual machine you wish to consume it. You can't take a virtual machine that is provisioned in standard VMFS volumes, including your gold, silver, bronze, storage I/O control volumes, and move it to vVols. No, this is the thing, you can't do that. You can't migrate existing. Oh, can you do a storage? You might be able to do a storage vMotion into a vVol. I'm not quite sure. I thought it had to be done at the time of creation of the virtual machine. There may be ways around that. Tony, look, I prefer to answer questions along the way because they're topical to the content on screen. We are very, very close to the end of, in fact, I think this is the second last slide. I'm sorry you feel that people asking questions is a waste of time, of your time. Virtual volumes, as I said, the diagrams, again, I promised lots of diagrams. So basically, your vSphere admin defines storage policies. Your virtual volumes are then defined that have and each of your virtual machines is assigned to a policy. As you can see here, it's using gold, silver, bronze as an example here. And what happens is that there's a control path that runs through VASA, which then determines on which storage within your storage environment your virtual machines will be placed, or the disks within those virtual machines will be placed. As you can see here, your storage device will provision or will publish its capabilities through VASA to vSphere. So it's two-way traffic. Vladimir, we discussed licensing for vVols. It's certainly available in Enterprise and Enterprise Plus. I think it's available in Standard. Yep, and John has confirmed that. So yes, available in Standard as of May 2015. So thank you, John. So this looks really complex, but it's all work that's done up front. A lot of this is done automatically. So your storage provider, if it is if it speaks the VASA language, can provide all this data itself automatically. And the work is done automatically. The whole idea of this is basically, as a vSphere admin, you say, give this VM this policy, and it happens automatically for you. Sorry, there was one last thing. Raw device mappings, we'll go through it very quickly. They basically allow a virtual machine to connect directly to underlying storage. So you may have an application which requires that it has direct access to storage from the SAN, so it might be a management application. It's good where your guest operating systems need to be able to share storage. So if you have a Windows cluster, as an example, where you've got a witness volume, then you'll have multiple virtual machines that need to access a single piece of storage. That can be done this way. You can't do that with VMFS volume, VMDKs. Application-aware SAN level snapshotting. So if you're using Exchange or SQL and you've got licenses on your SAN that allow it to take application-consistent snapshots, you generally need to do that through RDMs, or sometimes you can do it through iSCSI mappings, where the VM has iSCSI enabled and talks to your iSCSI. Or if you need to do block level replication from within a VM. So you need to control block level replication or storage level replication basically. HA, DRS, and vMotion operations are all supported. Effectively what happens is the virtual machine opens a VMFS or a file within the VMFS volume, which is a mapping file, which basically has information that says, here's where you should go looking on the storage provider for the LUN. And so I said before, and I put an asterisk on it, directly to the underlying storage. It's really not directly, it's via a proxy where the VMFS volume mapping file is used as a proxy for the virtual machine to access the map device. It opens it via the RDM file, but then all the reads and writes are done directly. So, labs. So I'd suggest is investigate the existing VMFS volumes in your lab. You will have some already because when you've done your initial install, a VMFS volume will be created. Add additional storage device to your environment if you can. So if you're running on raw hardware and you have access to storage, add it. If you're running within something like VMware Player, then add another virtual disk to your ESXi host and then add that virtual disk as a device within VMware. So then try migrating a VM to the new VMFS volume using thin provisioning. So you'll see the difference between thin and thick provisioning. Increase the size of your VMFS volume to maximize usage of the new storage. And you'll see before when I said create the VMFS volume to make it smaller than the maximum size. So you can see again you can extend VMFS volumes without impacting on the workloads that are running within them. You can also increase the size of the VMDK for your virtual machine. So you can actually go and increase the size of the VMDK file. You can't decrease it. And then open the guest and extend the volume that it sees on that disk. So if you go into your guest, and if it's a Windows box, rescan your disks, it'll show you there's now spare capacity on the virtual disk that you can extend your volume into. Stuart, I've been amazed as well. So Stuart Reed has commented that he's amazed by the creativity in some of the people's labs, the different ways that people have provisioned the labs. He's actually amazing. I'm actually hoping I've pinned some of the posts to the top of the forums to help people find them, but the number of ways that people have managed to get their labs up and going and the tools they've found has been amazing. Can you inflate thin provision to thick? Yes, you can. There are command line tools to do that, or what you can do, a way to do it without going to the command line is to do a storage vMotion operation on the virtual machine and change the provisioning style as part of that process. Paul, you mentioned providing they have Windows. There's actually some interesting Linux tools for doing it as well. If you look through the forums, you'll see quite a bit of stuff. Is it possible to download this webinar? It will be. I will very shortly go and convert the recording I've done to a more suitable format. I'll upload that to YouTube and it will also be uploaded onto the Learning portal. But other than that, if we have no more specific questions on the topic, I think I shall call it a day.
Well, we do have a few just that were flagged for maybe the end of the lecture. Some of them have left, and some of them might have actually already been answered. But we'll just see how we go. Sharon has asked, from a single SAN, 2 VMs are made, then how to control I/O?
So there are a number of different ways you could do that. You could create them on different LUNs off the SAN and limit the I/O on those LUNs. Generally, most of the way the SANs work is they provision a volume or they provision a LUN, and that LUN is basically spread across all of the disks that's available to it. So you end up getting the benefit of performance of all the disks through a very small individual LUN size. And that's, again, part of storage virtualization if you start looking at the storage level. How do you control, can one VM take all the IOPS capability and leave the other? Yes, through a process called storage IO control, which is a feature of Enterprise Plus.
Okay, thanks. Sotwin U has asked about whether NFS services will create an NSX server device.
No, entirely separate issue. So NSX, NFS is a way of consuming storage that is provisioned outside of your VMware environment. So you may have a Linux box, and traditionally it tends to be Unix systems that provide NFS as storage. NFS is effectively the file sharing solution that is offered in the Unix world. Under Windows, you would compare that to Windows file sharing, SMB or CIFS, depending on what you call it. So it requires a separate server to provision the NFS, but then it's just consumed by effectively your ESXi hosts become clients of that network files solution or network file service.
Okay. And one more from the questions I flagged. Can I apply vSAN with 2 servers only? From Jihad Degra.
I think it requires 3 because you do need the witness. Again, okay. If you'd like, just ping me in the forums as, hey, look, I asked in the webinar, can you confirm whether 2 or 3 is the minimum number of hosts required for vSAN, and I'll get you a definitive answer.
Alrighty, so that's all the questions we had flagged. We're getting a lot of thanks and see you laters. One more from Jerry has come in. Is it okay to have the OS drive on slower LUN than the data?
Absolutely. Absolutely it is.
Yeah.
Really, you should provision, especially if you're looking at provision different I/O capabilities per volume, then you provision what you need. Operating systems in general, your operating system disk is used fairly heavily when your virtual machine or when your workload boots, and other than the swap file within the virtual, within that operating system or workload, generally doesn't get touched an awful lot once the machine's running. So you probably don't need it on a high-speed disk. Certainly, even in the physical world, would provision, different speed disks for different things on a physical server. And taking a physical SQL server as an example, I might have used 10,000 RPM SCSI drives for the operating system, probably in something like RAID 1, so I got mirrors, and then for log files on a SQL box, I might have used RAID 10 with 15k RPM disks, because that's really where the actual work is being done by your SQL server. And then for your SQL database files, they need to be quick, but not really super quick, so you might use RAID 5 and 15,000 RPM disks, or even 10,000 RPM disks to provide sufficient speed. It depends also how your workload is designed, whether it's highly transactional or not. There's a bunch of issues, but in summary, you can absolutely have your operating system disk slower than your database data file disks. Absolutely.
Great. We've also had another comment from Jason. Jason's actually sent in a few good comments, so thanks for that. A note on NFS with VMware. Having too many VMDK files on a data store can cause VMs to boot more slowly. That
is certainly correct. That is one of the benefits of NFS, actually. And that is to do with the way VMware executes file locking in VMFS. So yeah, traditionally, and certainly with earlier versions of VMFS, it was more apparent, but they've improved the way the file locking is done on VMFS 5, but certainly on VMFS 3, I tended to stick to 1 or 2 terabyte or 1 terabyte volumes, basically, because it automatically limited the number of virtual machines I could have in a volume, which then meant that I didn't have to worry about the file servers or file services provided by VMFS slowing down as more and more VMs were booted. There was absolutely something you had to be careful of under VMFS version 3. It's still an issue under version 5, but not as much.
Alrighty, and perhaps one last question then from Raman. A server provisioned with SSD marks did not have local data store marked as SSD until changes were done on ESXi. What would be the performance differences with it on and off?
Performance differences, not much really. In the end, VMware asks for a file operation to be carried out, and the disk does it as quickly as possible, but you wouldn't be able to turn on certain functionalities. Now, I mentioned earlier that there are certain functions that require local SSD or flash disk, and you wouldn't be able to turn those on without having the disk marked as being flash.
Okay, there's one more from John as well. How does the VMDK file locking issues apply to vVols?
Largely in terms of the performance impact, it doesn't, because you've almost basically got a one-to-one relationship between VMFS volumes, or your virtual volumes, and your VMDK and your virtual machines at that point. So although it's done in containers, and the containers contain multiple files, but it's not as big an issue. And again, what's happened as well is the storage functionalities have become faster and more efficient through VAI and VASA and things like that, so you're getting better performance anyway. So it's becoming less of an issue as we go through.
Okay. All right, well, thanks very much, Robert, for sticking back again for all the questions. And thank you, everyone out there listening, for hanging around and listening. We've still got 200 of you left, so that's great. Keep sending your labs into the forums. They're really great work, and then a lot of really great work in terms of helping people out if they've got questions. So thank you for that. Keep up the collaborative learning. We might try and do a little bit of a showcase next week of some of the highlights from the forums. So yeah, if you've got any ideas, send them in. Thanks, Robert.
Thanks, everybody. Have a good day, evening, or whatever time it happens to be where you are. Cheers.